Alrighty, Sharp Customs coming to you with another video. Thursday night, we were supposed to get a great big huge freaking storm here in southern Ontario this evening. We pretty much got nothing. We got a little bit of rain, a little bit of wind. There's some pretty lightning happening up in the sky. Can't even hear it though. And aside of that, the lighting in our garage, this light, this light, this light, camera girl, Karen, my beautiful wife, she just said that that light over there over the lathe mill puts a halo over me. That ain't right. That ain't right. It's not right. A halo? Come on, really? So anyhow, let's move forward. We're rolling. We're rolling. So as you all know, we did the video with the copper cart. That was great. That was great. Thank you to everybody that watched it. Tonight we're doing something not really different. We're going to focus in on the mill lathe. I'm going to talk about a few things about it. It's a Maximat. It's an Emco, made in Austria. It's a Maximat V10-P. That's the name on it. I've looked at this thing all over the internet. They call the mill head the FB2. As everybody is aware, I've had issues with the gears inside there. They're made out of a I'm not really sure what the material is. It's this kind of material here. Those gears are all gone, as you can see. It's like a fibrous material. I call it phenolic. Other people call it another material. I will try and figure out what the heck it is. But anyhow, in this video, so I've been trying to fabricate parts for the GT40. Mainly kind of duplicating this unit here. Now I'm not going to make mine quite this fancy. This is, you know, goes out here, goes on the wheel hub, your control arms hooked to it. And of course I've been making brackets on the GT40. This one here, this was the original little piece of aluminum on there. Scrapped that, made a new piece. I was going to bend this the same as these. Kind of a good thing I didn't, because I want to keep the control arm centered to the basically the axle, the drive. And all I need to do, so this measurement from this point to the center and the center here to this point, all I got to do is I got to add a piece. And this one was cut a little weird. Basically this was cut too low to line up with this here hole. Doesn't matter. I'm just going to add these pieces. My holes will line up. I will have exactly the same distance, because the idea here is to make every single control arm, the top control arm, the lower control arm, make them all identical, all universal, so that they can be swapped. Because once there's a control arm on here, and I'm not sure how I'm going to make the control arms yet. I don't know if I'm going to cast them. Not sure if I'm just going to cut them out of aluminum. Not really sure. Never really know where I'm going with that type of stuff. But I got these shocks. They're off the donor Rayco Jackrabbit. And I'm thinking something like that. I might have to make another bracket up here or something. Might have to lengthen these studs, make another bracket over top. But I'm thinking, you know, probably something like that. Can't wait till I get there, you know, in the fabricating world. I think those will work good. They're a little long. You know, they're off a Jackrabbit, Rayco Jackrabbit, but I think I'm going to be able to utilize those. I don't think it should be a problem. So anyhow, I made nylon gears for that. We will get to that, but here's so basically I got these pieces here. They're off my modified 2 Rayco, and I didn't really duplicate them. I didn't really want to duplicate them. I just wanted something, you know, something similar, and this is basically what I've come up with. They're a little bit heavier, they're a little bit more solid, and I think they'll be fine. I plan on changing the control arms so that they fit in between here. You know, so they move up and down here with the suspension. You know, quarter scale, big boy toys. I try not to get too carried away. I try and think of the, you know, the simplest stuff to make. Yeah, they're a little bit heavy. This thing's still going to go like a bat out of hell once it's all done and, you know, whatnot. And, you know, yeah, these are a little heavier than these modified 2 ones that were made by Rayco. They're pretty sweet, though. I gotta say, they are pretty sweet. Now, I don't know how they were made. I don't think they were CNC machined back in the day, because I don't think CNC machining existed. They might have been cast, cleaned up. I'm not really sure. You know, I look at parts like this and I wonder, you know, 80s, 90s, I go, you know, how the hell did they make that? You know, I got my own methods. I did get these ones cut, cleaned up, got them milled out. Finally, it's only been days. But anyhow, let's move on to my main focus tonight is about this little unit here. I've watched lots of videos on YouTube. Not a lot of people talk about them. Don't get me wrong. These are old machines. They were built in Austria. I had some issues today. So basically what I did is I made 2 vinyl gears to replace the 2 that stripped out on me. And basically this is how I did it. I did it very simple. So yeah, I took one of these little axle thingies from my car, because just by putting a little piece of electrical tape on it, this little gear, this piece of nylon, kind of fit on there, and then it was kind of like, I only got a few teeth left, you know, half the teeth left on this gear. And I was like, oh, that's cool, because I can put those on there. I can scribe the teeth, and then I can rotate it, scribe more teeth, you know, rotate it, scribe more teeth. And you're probably wondering, well, how the heck did I cut those out? Well, I cut those out with a zip cut. Believe it or not. I cut those teeth out with a fine zip cut blade. Didn't take long. Didn't take long. Basically what I did is I did straight cuts in all the way around. There's 25 of them. There's 25 teeth on here. And I did straight cuts in to the V, and then I went around again and I did the angles with the zip cut. Very, you know, didn't take long. Didn't take long. But in the process of this whole, you know, making gears for the mill head, you know, we used the plasticine to try and cast a gear. Made a few resin gears. It's just polyester resin poured into the plasticine, just so that I had something to kind of mock off of. Did do an aluminum poured gear. Actually did a couple of them. Problem with, trying to cast the aluminum. I bought some Petrobond. I got a gear right here glued to a piece of, acrylic or Lexan, whatever it is. Made a little fixture, tried to sand cast it. That really didn't work out too well. I like casting aluminum. The only problem is that the aluminum does shrink. So, needless to say, this gear was a little sloppy in the head of the machine. Yeah, did all kinds of stuff. I got some plaster casts with, actually used this. I made a Bondo. This is Bondo. Made a Bondo mold of the gear. Had to PVA it and then hot glued. Just put the hot glue in there. Okay? Put a couple stems of hot glue sticks on the gear. Pulled them out. Yeah, I made the noise. Pulled them out. And they are now embedded into, my little plaster castings here. And once the plaster's dry, I kind of changed my thought. I was going to pour aluminum into these, and I thought, aluminum really shrinks. Why not try the brass? Maybe do brass. Maybe do bronze. Probably brass, a little softer. But anyhow, I got two of them. Once they're good and cured, to try. Because I did the nylon gears in this unit right here. Put this all back together today. And I ran it with the nylon gears. The nylon gears, everything moved nice and free. If there was, because I had this unit on the bench, and when I put the gears together in there, I actually had a piece of 1/2-inch steel in the collet, and I spun it with my cordless drill. Make sure there was no binding, make sure it was smooth. Put grease on them. Everything seemed to be good, And I've watched other videos where people actually bought 3D printed gears, and I'm like, are you kidding me? You can put some plastic 3D gears in a machine? I actually commented to these people on YouTube, and theirs were a fail. They were a fail, the 3D printed gears. It was kind of nice that these people got back to me and told me that the 3D printed ones, yeah, they don't do shit, hey? They just don't last. Also watched another video of a fella who, used all the fancy equipment. Of course, I didn't use the fancy equipment. I used a zip cut and cut my nylon and made the gears, and they're not perfect. I'll give you that. They are not perfect, but I made them so that they rotated nice. There was no binding whatsoever, and I figured, oh, well, the nylon, it's got a little bit of give. Got them pressed onto the shafts nicely. Epoxied them. Everything seemed to be working good. You fire it up. It's a little loud. But basically what happened is 10 minutes into literally taking some very light cuts on aluminum, nonetheless. I had it in a higher gear. I think I had it on the 940. Yeah, my one main idler gear, made of nylon, glued onto the shaft, pinned so it couldn't slip. We're talking You know, we're talking, the pins I used were like, they're like maybe 1 thou little roll pins, split pins. Drilled them, put them in, you know, pushed them in, and that gear is non-existent. That was the first one to go, and it was the best one that I made, and it's non-existent. I don't know where it is in the head, but I took these little side plates off. There's 2 little side plates here, so you can kind of inspect, you can look inside there, and as you can see down here, we got little white pieces. Yeah, that's the nylon. Those are the teeth. But as far as up inside there, where the gear resides, it's not even up there. I don't even know where the hell the gear is, but it's just not there. But I do have 1 speed. It's my low speed. And I don't even know how that's working, because when I looked up in there with it running with the flashlight, only half the gear, so the thickness of the gear is a little over 300 thou. The half of the teeth are missing on the gear, but it's working. And it basically got me where I needed to be, with at least with these 2 pieces. I do love this machine, and you know, I went through a lot of crazy stuff with this today, because when I had this off, basically I cut the wires. I got the MAR connected together, and those crazy Austrians, I'm gonna say, okay, I got a black wire, a white wire, and a green wire. Well, you know, over here, the green is generally ground with electrical. This was hanging down here like this, and I only put the 2 orange MAR connectors on so I could test this. And then I wheeled the bed, you know, this was hanging, I wheeled the bed over, and it touched the ground, and it did this big arc thing on the green. And I was like, what the heck? Of course, the whole machine shut down. So I'm thinking, okay, somewhere in this machine, there's got to be a fuse, a breaker, you know, something like that, which there is underneath this this button box, you know, to turn things on. There's like, basically what they look like to me is they kind of look like contactor switches inside a MIG welder. But in order for me to get this back cover plate off, I had to unbolt this, move it all forward. Of course, they used slotted screws in the back of this cover plate. I thought they'd be Allen keys, just like the rest of the machine. It's all hex head bolts and stuff. No, they're slot screws. But I got them out. I got them out with a pair of vice grips. Got it slid forward, started looking at stuff, and there is 2 kind of inline fuses, one for the FB2 mill head, and there's one for the lathe. Well, both of those, I just use the, basically, with the voltmeter, you know, I use this. Yeah, I use that. I can't remember what it's called. I know what it is. I just can't think of it at the moment. Continuity tester. That's it. You know, makes the beeping noise. And I checked both those inline fuses. They're great. They're still functional. And there's 2 big old cigar-looking capacitors back there, and they're just kind of floating around in there. And I was like, you know, I hope I didn't fry one of the capacitors, you know, zapping it out. And then I had this cheesy old, here, I'll show you. This is how cheesy, this is my cord that was on it. And this thing is so ratty. Like, look at this. The rubber, it just falls apart. Even Look at this. Even the coatings on the wire. Look how easy that comes off. Hey? But it was so cheesy. I was like, I'm going to use the continuity tester. I'm going to do each one of these prongs into the box. The ground work, the white wire work, the black wire dam work. And what it turned out to be one of these. The little fitting that basically goes on the back of the, the little contactor. Basically, it was just being held on there by like a little piece of the rubber coating, and the wire had actually fried back. So basically I put a new cord, and then I noticed when I got the lathe part of it up and running, fixing this, I noticed when I tried the mill head, I pressed the white button for the mill, it didn't go. And I wiggled the little wire on the contactor in the electrical box, and guess what? Same dang fitting was just barely hanging there, by a thread of wire. Just the rubber was kind of holding it there, and when the vibration would make it go, and it's like, and I get it, you know what, this machine is old, and I just kind of wanted to touch on the Emco Maximat, whatever you want to call it. But so yes, the nylon gears, only got 420. That's the only gear. It's not going to last long. I know I did hog these out. Pretty heavy. I did hog them out, because that's the way I use my tools, man. This whole thing was like, the bed and the vise and everything, it was shaking while I was hogging these things out, taking 100 thou cuts, and I think that these little machines, they're built so well, they should be able to take that. And it's still working, but I am going to make some new gears, and I think what I'm going to do is I'm going to probably create a fixture to go on the bed where I can spin a carbide bit in the profile of the gear. Now I know you can get all these fancy tools, you can get an indexer and all this stuff to kind of help you along with doing a gear. It does it, actually the ratios are perfect. You just rotate it, you cut it, you rotate it, you cut it, you rotate it. I don't play that game. Listen to that rain. It's just frickin' pouring out. That's wild. But no, I will create my own fixture that mounts to the bed, and I can actually utilize the lathe part. Basically, I'll give you. I'll just grab one of these gears here. So I'll create a fixture that mounts on here where the vise is at the moment, and I'll have almost like a boring bar with a carbide cutter cut to the gear profile, where this just sits there like that. This spins the cutter blade, and I can just index this like this. I can just turn it, cut it, go in and out. Bring it back, rotate it, cut it, rotate it in and out, cut it, and me making my own tools, to kind of do something like that is more satisfaction than the two pieces in here, I actually found them on eBay. They're used parts, they're a little bit worn. Obviously that, would I have bought them? Would have been about $200 Canadian. I might have bought them, but the particular person, the eBay seller, doesn't ship international, so I would have to figure out some way to get one of my stateside buddies to, maybe purchase them and then mail them to me and all that kind of stuff. But anyhow, yeah, these are kind of an underrated machine. I do have it back up and working. It's not working perfect, but I will get it there. I'm thinking of cutting up some, some brass gears for it. And I don't think they'll be too hard on the steel gears that are in there. I wanted to keep this video short. I always say that. I know it. Thank you to all my new subscribers. Thank you to all my regular subscribers. Sharp Customs. Share, like, subscribe, comment. I love to read comments. I love to reply to comments. And that's our video for tonight. So, peace. I'm out.